For reversible processes, work done in a process from 1 to 2 is equal to integral of P dV. In order to carry out this integration, we need to convert P into some form of V using the equations applicable in that process. In an isothermal process, temperature remains constant. But from ideal gas equation, PV is equal to mR specific T. So, for a given closed system, the mass of gas, the value of R specific, and the temperature, all three terms on the RHS become constant. Hence, for an isothermal process, PV is equal to constant. We can substitute this value of P in the equation for work done. Taking the constant out and integrating, we get work done is equal to constant into log V from V1 to V2, or is equal to constant into log V2 by V1. This is the equation for work done in an isothermal process. The value of constant can be replaced using the value of PV or mR specific T, whatever is available in the given situation. In an isobaric process, pressure remains constant. Then, the equation for work done becomes integral of constant into dV from V1 to V2. We can take out this constant, which has the value of pressure, and integrate, which gives us the work done in an isobaric process, as P into V2 minus V1. In an isochoric process, volume remains constant, or V2 is equal to V1. Then, the equation for work done becomes integral of P dV from V1 to V1. Hence, work done in an isochoric process is 0. For a polytropic process, the general equation is PV raised to n is equal to constant. As the value of n changes, this can be used to represent any type of process. When the value of n is equal to gamma, that is the ratio of specific heats, it becomes an adiabatic process. So generally, the equation can be rearranged as P is equal to constant by V raised to n. We can substitute this in the equation for work done. Taking the constant out and integrating, we get work done is equal to constant into V raised to minus n plus 1 divided by minus n plus 1 from V1 to V2, or is equal to constant by 1 minus n into V2 raised to 1 minus n minus V1 raised to 1 minus n. This is the equation for work done in a polytropic process. When the value of n is equal to gamma, it becomes the equation for work done in an adiabatic process. The constant can be replaced using the value of PV raised to n according to the information available for the given situation.